Hello, Senior One. I hope that you are fine. Today we'll have a chemistry lesson about the mole calculation. Today we're going to revise some of the concepts that we've taken about the mole calculations and solve some of the problems on it. As you remember that I told you before, what is the mole? The mole is the measuring unit for the amount of substance or the amount of matter that we use in chemistry. And each one mole of any substance has equivalent. 1 mole equals the molar mass of this substance or the atomic mass of this substance. If it's an element, so it represents the atomic mass. If it's a compound, so we calculate the molar mass by gram. And we measure the molar mass in grams. It's the summation of all the masses that form the compound. And each one mole equal the molar mass and equal what is we call the Avogadro number of particles. That is equal 6.02 times 10 to the power of 23 particles. And the particles in chemistry may be atoms, may be ions, may be molecules, may be a formula unit. Okay, so all of this represents the type of particles in chemistry. And at last, it's equal 22.4 liter or the volume of any gases. This is the equivalent of the mole. And we can do this in the magic triangle as we learned before. So we can calculate the mole by dividing the mass over molar mass. Or we can calculate the mole by dividing the volume by 22 in liter, of course, by 22.4 liter. Or we can calculate the mole by dividing the number of particles that we have over the Avogadro's number, which is 6.02 times 10 to the power of 23. So this is the 3 rules that we can use to calculate the number of moles. And I'll give you an example. If you have a 1 mole of the sodium, we have just 1 mole of sodium sulfate, okay? This contains 2 mole of sodium ion and 1 mole of sulfate ion, and it contains also 2 mole of sodium atom and 1 mole of sulfur atom and 4 mole of oxygen atom. This is for clarification. So we're gonna solve some of this problem or some of the problem about the mole calculations right now. We start with the first question here. What is the number of the atoms? So he asks about the atoms in the formula unit of the calcium bicarbonate. He writes that we have Ca, H, CO3, all 2. This is the calcium carbonate. He asks you about the number of the atoms. As you see here, that we have 1 calcium atom, and we have 2 hydrogen atom, and we have 2 carbon atom, and we have 6 oxygen atom. So to calculate the number of the atoms, we have to add them together. It's 11 atoms. So this is the number of the atom of the formula unit, or this compound, the ionic compound called the formula unit. So this is the formula unit of the calcium bicarbonate. Next, a mole of potassium dichromate contains what? Potassium dichromate, its symbol is K, Cr2O7. As you know that we have valency 1 here and valency 2 here, we're gonna exchange, so the potassium dichromate gonna be K2Cr2O7. How many mole of potassium here do we have? We have 2 mole of potassium, and we have 2 mole of chromium, and we have 7 mole of oxygen. So the answer will be the potassium dichromate contains 7 mole of oxygen. Okay. Then, which of the following molecules, a mole of it contains the highest number of the mole of the atom? So I need to find the highest number of the atoms. We have S8, S8 contains 8 mole of atoms. We have C10H8, we have 18 mole of atoms, 10 for carbon and 8 for hydrogen. Al2SO4, all 3. We have 2 for aluminium with 3 for sulfur, so it's 5, and we have 12. Here we have 17 mole of atoms. Then we have Na3PO4. We have 3 and 1, 4, 4 plus 4, it's 8 mole of atoms. So the biggest number or the largest number is the C10H8. It's number B, as you see here. Okay. Then we have an equation that represents the burning of the propane. We're gonna copy it here. Okay. So C3H8 plus 5O2 to give 3CO2 plus 4H2O. Which of the following represents the correct ratio between the oxygen and the propane gases as reactant? I want to find the percent of the oxygen to the propane gas. So we have 5 mole of the oxygen molecules, and we have 1 mole of the, just we have to make sure that it's a balanced equation. We have 3 carbon here, we have 3 carbon here, we have 8 hydrogen here, we have 8 hydrogen here. So it's 6 oxygen plus 4, it's 10, and here we have 10, so it's a balanced chemical equation. So the ratio will be 5:1, and the answer will be 5 mole to 1 mole, as you see here. Next. Here we're gonna solve problems about the molar mass. The ratio between the molar mass of the solid phosphorus to that of the phosphorus in its vapor state. To just memorize you about the difference between the both states, we have phosphorus and we have sulfur. All of them has different physical states. The sulfur in the vapor state represents as B4, and the phosphorus in the solid states represents as P only. Sulfur in the vapor state, it's S8, and in the solid state, it's S only. So when we return back to the question, he asks you to find the ratio between the molar mass of the solid phosphorus, which is P1, over the vapor P4, and its molar mass of the atomic mass for the phosphorus is 31. So we're gonna divide it 31 over 4 times 31. It's gonna be 1 to 4. So the ratio will be 1 to 4, as you see here. What is the molar mass of the barium sulfide? We have to write the barium sulfide first. Barium Ba, sulfide SO3. Here we have divalent and divalent, they cancel each other. So each one barium equal 137 plus each one sulfur equal the atomic mass for the sulfur is 32 and the atomic mass for the oxygen is 16 multiplied by 3. The total molar mass we calculated and find it by gram per mole. This is the total molar mass for the barium sulfide. So what is the mass of aluminium in? Here, what is the mass of aluminium in? 306 grams of aluminium oxide. So, you know, we have that each mole equal the mass of molar mass. If we divide to find the number of mole equal the 306 divided the molar mass of the aluminium oxide, which is 2 times 27 plus 3 times 16, it's gonna be 3. So this mass represents 3 mole. So we have 3 mole of Al2O3. He wants to find the mass of aluminium. So it's gonna be 3 times 2 times the mass of 1 aluminium, which is 27, it's gonna be 162 grams. Okay, next. If the molar mass of MOH3 equal 78, so we have a compound called MOH3. So the valency of the M is 3 equals 78 gram per mole. So the gram atomic mass of the element, he wants to find the gram atomic mass for the element this. It represents the M plus 3 times O. This is the total mass plus 3 times H. We're gonna substitute each one of them by its atomic mass. So M plus 3 times 16 plus 3 gonna be 78. M plus 3 times 60 gonna be 48 plus 3, so gonna be 47. 48 plus 3 gonna be 51. Sorry, equal 78. Make it in the other side of the equation. It's 78 minus 51. It's gonna be 2. It's 27. So it's the aluminium, if you know. The atomic mass of the aluminium is gonna be 27. Okay. If the chemical formula of the antimony oxide is Sp2O3 and that of the sodium phosphate is the Na3PO4, what is the molar mass of the antimony phosphate? So we're gonna write here that the antimony phosphate Sp2O3 should, he gives you this formula to just understand that the antimony has a valency of 3, okay? And the sodium phosphate, it's written like this because the sodium is a monovalent and the phosphate is a trivalent. So to write the antimony phosphate, you're gonna write it in this chemical formula, SpPO4, because antimony is the trivalent, phosphate is a trivalent, and we're gonna add them together. Antimony equals 121.8 plus 1 phosphorus by 31 plus 4 times 16, and we're gonna calculate it. It's found by gram per mole. Okay. Then we have another question about element X. Its gram atomic mass is 32 and its electronic configuration is 286. Why gives you this electronic configuration? So just know that it's a divalent, because if the element is 286, so the last level has 6 electrons, so it's gonna complete its outer level by gaining 2 electrons or sharing it by 2 electrons. So it's a divalent and it's non-metal. This element, it's a divalent, okay, non-metal, divalent, and its atomic mass is 32. This element X. And another element is element Y. Its gram mass is 35.5, so it's 35.5. This is the gram mass of it. And its electronic configuration is 287. It's 287. So as you know, that it ends with 7 electrons, so it's gonna complete its outer level to be stable with 1, whether by sharing or gaining it. So it's -1 or it's monovalent. What is the gram molecular mass of the compound produced from combining the atoms of the two elements X and Y? If you combine X and Y, this is divalent and this is monovalent. We're gonna exchange this. So the 2 goes here and the 1 goes here. So it's gonna be XY2. So substitute each one with its molar mass or atomic mass, gram atomic mass. So it's 32 plus 2 times 35.5, 71 plus 32, it's a 303. It's 103 gram. So it will be 103 gram per mole. Okay. What is the molar mass of a compound produced from combination of the potassium element with the selenium element, which lies in the same group of the oxygen? This point shows you that the selenium is a divalent. So if you bring potassium with selenium, which is divalent, it's gonna be K2Se in the same group of the oxygen, okay? And he wants to find the molar mass of this compound. So it's formed from 2K plus 1 Se, 2 times 39 plus 79. So it's almost 157 gram per mole. Next. What is the number of the mole of phosphorus vapor P4, which can be separated from the mixture of 4 mole of Ca3PO4O2 with 5 mole of P4O10 and 6 mole of H3PO4. So here, this is question number 12. Suppose that you have a Ca3PO4O2. It contains 2 phosphorus. So number of phosphorus here equals we have here 4 mole of it. So if we have 4 mole of this, we're gonna multiply this by 4 too. Gonna be 8 mole. Next, if you have 5 mole of P4O10, it's gonna be 5 multiplied by the 4, so it's gonna be 20 mole. It's gonna be 20 mole in this P4O10. Okay. Next, we have 6 mole min H3PO4, so it's 6 multiply 1, gonna be 6 mole. So the total number of mole of P equal 8 plus, as I write in here, 8 plus 20 plus 6. It's gonna be 28, 34 mole. And each P in vapor state is P4. We're gonna divide it, the 34 mole of single P over 4, it will be 8.25 mole. So the correct answer will be 8.5 mole. So we find the total number of the P here, and the total number of mole of P here, and the total number of mole of P here, and add them together and divide it by 4. Why? Divided by 4 because the vapor state of the phosphorus is P4, represents as P4. So we're gonna find the total number of B4 or P phosphorus in the vapor state can be separated in this form, will be 8.5 mole. Okay. Next, calculations of the number of moles. Which of these samples contains the highest number of moles of the carbon atoms? So we have 4 compounds. Each one of them contains a number of grams. We have here 29 grams, and we have here 23 grams. We have here 22 grams, and we have here 90 grams of this compound. And we want to find which one of these samples contained the highest number of the mole of the carbon atom. So we have to find the total number of moles in each one of them. Mole represents as mass over molar mass. The number of mole will be mass over molar mass. So here gonna be 29 over 4 times 12 plus 18, gonna be half mole. Here it's 23 over 2 times 12 plus 6 plus 16, gonna be half mole too. Here we have 22 over 12 plus 2 times 16, it's gonna be half mole too. So they are equal up to now. Here we have 90 mass over molar mass, 6 times 12 plus 12 plus 6 times 16, it's gonna be half mole too. So all of them equals half mole of each one of them. So when we bring C4H18, each 1 mole of it contains 4 mole of carbon here. Suppose that we have half. How many more of carbon We'll make the crisscross. So here we'll have 2 moles. Next, each 1 mole of C2H5OH represent 2 moles من الكربون. Suppose that we have half. So what is the number? 2 times half, gonna be 1 mole. Next, HCO2, 1 mole of it contains 1 mole of carbon. So if we have half mole, so it's half mole too of carbon. We find the highest number of carbon atom. C6H12O6, each 1 mole contains 6 mole of carbon. So if we have half, we're gonna have 3 moles. So this is the largest number of the carbon atoms we have. So we're gonna choose the 90 gram of C6H12O6. Which of the following sample contain the same number of moles of the CaCO4 in 272 gram of it? So, wait. This is gonna be the last question, inshallah. Okay. So suppose that you have which of the following sample contain the same number of moles of CaSO4? We have CaSO4 calcium sulfate, and we have in 272 gram of it. So molar mass of the calcium sulfate, we're gonna find the molar mass, which is equal 1 calcium plus 1 sulfur plus 4 oxygen. We're gonna substitute each one with its atomic number, atomic mass. So it's 32 plus 4 times 16. It's gonna be the total molar mass of it will be 136. Okay, so and the number of mole will be the mass over the molar mass. So it's gonna be mass over molar mass. It's gonna be 272 over 136. It's gonna be 2 mole. So we have 2 mole. We have to find how many mole of each one of them. We're gonna divide it, the mass over molar mass for each one of these choices to find the correct answer. So mole of chlorine gas gonna be the mass, which is 142 gram over 2 times 35.5. This is the atomic mass for the chlorine. It will be 2 moles. So it's the same. So this is the correct answer. Will be the 142 grams of the chlorine. Thank you for today, and I hope that you understand well. See you soon, inshallah.